Okay. Are you all mentally tired?
Yes. Physically as well.
Yeah, tell me about it. What to do? That goes on. Okay, so now we have seen the structures of memory. What we have seen so far is what is the capacity of program memory, what is the capacity of data memory, and how to derive the address ranges for both this memory. Is that okay? Then we also saw some special function register, we saw what's pipelining. Now we're going to go into the instruction set. I hope all of you have printed out the instruction set. This is the instruction set. So please make sure print it and always bring for your lectures and also all the tutorials. This will be your reference point all the time. So make sure always bring this along with you. Is it okay? Now before we actually go into this study in depth about this instruction set, let us see some few things first. Now because we have two memories, one is known as program memory and the other one is data memory. So what do we do with the program memory? We store the program. What we do with the data memory? We store the data. Now what you are seeing here, is this data or program?
Program.
This is the program. This is the assembly language which we are going to write in the compiler or the... Have you all downloaded and installed the MPLAB?
No.
Installed it, yeah? So this is what we are going to type in the compiler, the IDE. Okay? Now each one of this instruction consists of 16 bits instruction word. So that means one instruction is actually takes up 16 bit minimum. So I think, did I go through the terms? One word equals to double byte.
Yes.
All that done, did I? Did I also explain about 16-bit thing? Got it. Okay. So one instruction takes 16-bit. So all the instructions are 16-bit except for 4 instructions. For example, this one is actually 32 bits. That one instruction requires 32 bits. So out of 77 instructions, 4 out of 77 instructions is 32 bits. The remaining are all 16 bits. So this 16 bit, this is actually the program. This is mnemonic representation. Did I mention that in class? No, so where did I mention it? So this is also known as the machine code, which means this is what will be stored in the program memory. We as the users, we actually write this in our MPLAB compiler, IDE, right? We type, and then when we compile, the output file actually generates this one. And this output file is what we're going to load here. And all this program will be loaded here. Do you get it?
Yes.
Are you following? Now the thing here is, Here you have 16 bits, but here only can store 8 bits. So how do we actually store this? We divide into two locations. This is 16 bit, right? So we have the lower byte and also we have the higher byte. The lower byte is stored in the lower address, the higher byte stored in the higher address. So let's say if it's like this. This range is just a sample. Later you'll see that we won't be starting program from zero. It will be different. I didn't go through this. No. So this is, let's say the instruction consists of 16 bytes. For one location we can only store 8 bits. So the lower byte will be stored in the lower address because the address increases like this, right? And then the higher byte is stored at higher address. So which means one instruction takes two locations. One instruction minimum takes 2 locations, except for the small instruction which is 32 bit long, it will take 4 locations. 4 locations. You are getting? Okay or not okay? You just need to know that one instruction is 16 bits, and how is it stored in the program memory, because the instructions are programmed, right? They are stored in the program memory, and program memory one location can only store 1 byte or 8 bits. So how do we store? It's broken into 2. The lower byte is stored in the lower address, higher byte is stored in higher address. Is it simple or difficult? Okay, okay. Now, do you remember PC?
Yeah.
What is PC?
PC program counter.
What is the function of program counter?
Keeps track of the
Keeps track of the
address of
next address of the next instruction.
address of the next instruction.
Ah, yes. Keeps track of the address of the next instruction to be executed. So when you first, this is also known as what? This address 0?
Reset vector.
Yes, it's also known as reset vector. So automatically the PC will come here. So when initially is pointing here, what it will do? It will fetch the first instruction. We just read the pipelining, right? And what will happen to the PC? It will point to the next instruction, right? Where is the next instruction? It is at 0, 2. Why it is skipping by 1? Because one instruction takes 2 locations to store. So you will notice that your PC will keep jumping to even numbers, 0, 2, 4, even addresses. The reason is because of that. One instruction takes 2 locations. So later on when you use the MPLAB, you can actually debugging, you can see the PC jumping, the address will change. The address will change from 0, it will never go to even odd address. Reason is this, because it takes one whole thing. So when it's pointing here, when it fetch, it will also fetch low and also high together. So that's why it doesn't point here. It actually says we point to the even one, it will jump by 1. Is it okay? So what I want you to understand from here is why the PC actually jumping by 1. It is because one instruction takes 2 locations to store. That is why. Any question up to this point? Yes or yes? There's something you need to recall back on the memory technology. When you turn off the power, will the content inside the program memory disappear?
Program memory.
Again, I repeating. Inside program memory, you have program. When you turn off the power of the whatever microcontroller, when you on back, does the memory still have the content or not?
No.
Why no? And why yes?
Microcontroller is something like ROM.
Okay, you're telling what?
ROM is read on memory.
So, disappear or not disappear?
That's
You won't disappear. You're telling? Disappear. What?
The program doesn't run anymore. Then how? Every time it starts again, doesn't it start at a reset?
Good point. But a good analogy that we can use is your computer. Each time you turn off your computer on back, it doesn't ask you to install back software, right? Just imagine on back, please install OS. Put back install for 2 hours. Then off back is scared to off, you know. The thing is, the program memory cannot be, we cannot use the technology which erase. Of course, the point you mentioned that it resets back, that's correct. Whenever you on, it resets back. The PC resets back. But the content shouldn't reset. If the content resets each time you on, there's nothing will happen. Then you will scared to off the thing. So, therefore, program memory should use ROM technology. Now we have so many ROM technologies, right? Program memory is using flash memory technology. Okay? It's using flash memory. This PM, Prime Minister. Program memory is of RAM technology and is using flash memory. Is it okay? And then you have data memory. Data memory is, when you off, will it disappear?
Disappear.
It will disappear because it is RAM. And it is what technology? It is static RAM. So it is SRAM. So data memory is SRAM, whereas program memory is flash memory. So whatever you store in program memory will always retain, whereas whatever in data memory, if you off, on back, it will disappear. Is it okay?
Flash ROM. Flash ROM. Flash ROM.
Flash memory.
Flash memory.
You have learned that right under ROM, that's flash memory. Any question about this one? Now we have seen this. We're going to see, now since we are talking about the instructions, right? Each instruction has a 16-bit length. And it is, how is it stored in the program memory? We have seen that. Now we're going to go into the subject matter of the instruction operation itself. Now the instruction has 6 types of operation. Of course, I've only written 5 because the 6th one we will see in chapter 2. Of course, this one also we'll see in chapter 2. Up to now, we'll actually do until 4. Excuse
அவள் ஒரு நல்ல ரிங்டோன் வைத்து
Data. Data.
RAM and static memory. Data memory means RAM. Where RAM comes under static memory. Static memory comes under RAM. Clear. ROM does not clear.
Now, the reason why I'm not giving 5 minutes break in between is I'm always taking break like that, so you'll get the break in between. When I stop, the instruction. So out of this different type of instruction, the 6th one we'll see in chapter 2, the 5th one also we'll see in chapter 2, we'll see until the 4th. Okay, what do I mean by types of instruction operation? There are few types of operation. They are byte-oriented operation, they are byte-to-byte, bit-oriented operation, and literal operation. Now, if you see your instruction set, all these are instruction set. These instructions are already categorized by the type of operation. Is the English easy to understand? The instructions are categorized based on their operation. So, all these instructions are byte-oriented operation. So the instruction set has already categorized for you. The reason is, later on when we do tutorial 2, when we given a particular task, how we will know which instruction to use is, we will first identify what type of operation is this. Based on that, we will know where to search for the instruction. That's why it is categorized by operation. These instructions are bit-oriented operations. These are all control-oriented operations. These are literal operations, and this is the sixth one which I mentioned, which I won't mention now. We'll see in chapter 2. Is it okay? So now what we're going to do is we're going to see what do they mean by byte-oriented operation and byte-to-byte, bit-oriented and literal. I actually find it very, very difficult. Very tiring. No, it's not tiring, it's very, very hungry. Hungry. Is it fun?
Let's go.
No, to speak for 3 hours, that's a lot. Okay, let's take the first one, byte-oriented operation. Now, what do they mean by byte-oriented operation is, like just now we did this addition operation, right? Let's take a simple example, addition. Now again, don't worry about how we will do this. I just want you to understand the type of operation. What do they mean by byte-oriented operation? So here, example that we are seeing is an addition operation. When you want to, there's another thing I forgot to mention. I don't know whether I mentioned or not. All the instruction, or almost all the instructions in the PIC, this the processor doesn't work. So all the instruction in the instruction set is actually being executed on the data memory. You understand? All the instructions that you see here, the execution part is done on the data memory. Why? Because all the data are in the data memory. So all the instruction, even though it's stored in program memory, the fetching part only comes from program memory. Remember there's two stages, fetching and execution. Fetching, yes, the control unit fetches from the program memory, but the execution is done on data memory. Okay? So let's say you're performing addition of two locations from data memory. Can you give one sample address of data memory in hex?
0x.
How many hex digit must the address be for data memory?
032.
03. The address of data memory, any data memory location must be 3 hex digit address, right? Byte 3?
The first
12 bits. Can you give another address here?
0x 123.
0?
123.
1 to 3. Yeah. Okay, two addresses. So now when you want to actually add these two content of these two addresses, can you give one sample data inside here in hex?
7c.
Is this a valid value? Is 7c a valid value? Why yes? Because it is 8 bit, so it's valid. 7c is 8 bit, so it's valid. That's all I'm here. Another example?
1d.
FF.
DD.
Am I FF already? DD we covered just now already. FF. So now, can you imagine this? Of course you are seeing this. This is the address of this file location. Inside this file location there is this value. And then you have another file location. Both are in data memory. You have another content. So this operation of adding these two, what happens is you are taking 1 byte value, you are adding to another byte, then you will get a 1 byte answer result. So this type of operations are known as byte oriented operation. Why? Because it deals with one whole byte. It takes this chunk of 1 byte, it adds to this another chunk of 1 byte, and the answer you get another chunk of 1 byte. So this type of, or it could be subtraction, 1 byte subtract 1 byte, or maybe then 1 byte you perform logical AND operation on top of the 1 byte, or you perform toggle on the 1 byte. So the whole byte gets toggled. So any operation which changes or manipulates the whole 1 byte is known as byte oriented operation. Is it okay? Don't worry about, sir, what type of operation? Now you will see later. Just understand this point, that any operation that changes the whole or manipulates the whole byte, that is known as byte oriented operation. Is it okay? Okay, okay.
So, the test asks us the definition of all these things?
No.
Then okay.
No, test. No, this is not about definition.
Understanding.
I'm telling you understanding. What? So that you can differentiate between the type of operation. Of course, this one, if this one asked definition, I would have mentioned you. This is the very important definition for you to actually see and understand. Please memorize this. But no, it's just for you to understand. This is not even design. Okay? Of course, we'll see the next one so that it will be easy for you to actually identify the type of operation. Is it okay? Can we move on to the next one?
Yeah.
And then you have byte to byte oriented operation. Now, for this operation, there is the best thing is there's only one instruction which can do that, which is known as move file register to file register. Move file register to file register. Remember the term file register?
Yeah.
File register is also referring to memory location. Is also referred to as register. The same thing. Move FF is here. Right? Now, if you notice that there is no separate category for byte to byte oriented operation, because byte to byte is also under byte oriented operation, but it is known as byte to byte. So what do you mean by byte to byte is, assuming that you have two locations in data memory, let's say the first one is maybe a hex 200, second one a hex 400. Can you give another sample data inside data memory?
1E.
What?
1E.
One. The other one? No, it's not okay. So when you say byte to byte oriented operation means you take this content, you copy and paste here. This is known as, so that means when you copy and paste. So here also you have hex 21. So this operation, the operation which copy and paste to another location is known as byte to byte operation. And there's only one operation. There's only one instruction which can do this operation, which is move FF, move from file register to file register. Now in digital hardware, take note that there is no such thing as cut and paste. You know what's the difference between cut and paste and copy and paste?
Yeah.
Copy and paste means the original file which you copied still remains, whereas cut means the original file disappears. Here the concept is copy and paste. That means you duplicate and then you paste it here. The original data will always remain until you replace it or overwrite it with another value. Is it okay? So this is byte to byte operation, and there's only one instruction which can perform this operation, which is move FF. Is it okay? Can we move to the next one?
Yeah.
The third one is bit oriented operation. Now let's take one location. We take one location out from data memory. Any address that you want to recommend? Any address from data memory? 001.
007.
James Bond.
Since James Bond Spectre is coming out, so we celebrate. Do you know why the special agent is known as 007?
Because he's the agent of the 7 weeks device.
Does it matter?
Actually, I don't know if you ask me.
The 7th agent who survived.
I know, it's actually 7 agent. The old lady tells the story.
Yeah.
Okay, now we actually taking this one location and we are zooming it, we make it bigger. So in one memory location, how many bits do we have? 8 bits. So let us actually label them. bit number 0, 1, 2, 3, 4, 5, 6, 7. Okay. So let us assume inside this location there are already some values. So I'm just going to put some dummy values here. So assume there are some values inside here. Now, the instruction, the bit-oriented instruction means, the bit-oriented operation means you use that particular instructions to just manipulate the particular bit only. That means you can use instruction to only make this particular bit from 1, you can make it 0. Of course, we are not seeing what is the instruction, but they are instructions which can just manipulate the bits only instead of the whole byte. So that therefore, those type of instructions which allows us to just manipulate the bits, they are known as bit-oriented operations. Is it okay? Yes? This one you understand? Any instructions that allows us to just manipulate the bit. I mean, for example, this is 1. I just want to make this bit to become 0. Yes, set or clear. So I'm just manipulating this one. The rest I'm not disturbing. So, am I manipulating the whole byte or just manipulating the bit? The bit. So, any instruction that allows to do such operation is known as, they falls under the bit-oriented operation category. Is it okay? I'm just giving an overview. Later we'll see the exact instruction. Is it okay or okay? Next is literal operation. Can I erase that side?
Yes.
We'll try to end with literal operation. Okay? Control operation we'll see in chapter 2. Again, in all our example, if you notice that I'm taking the example of data memory. Why? Because as I mentioned, all the execution are done on data memory. That's why all this memory location I'm using data memory as an example. So can you give another address from data memory?
0 D4
999. Speak of the devil.
It's not 56, man?
Huh? I know like Bali. This one all very sharp. Never mind, at least you sharp. Okay, now literal operation means, literal means value. Literal means value. So earlier I told that assume there is some content. Assume this now got some value when you want to perform addition. Now this literal operation is the operation which allows us to load the value inside the address. So let's say now we have this address 999. What is the value that you want to load inside? Any value? 1. So you have this value hex 11. Is this a valid value? Why? Yes, it's within 8 range, so fine. So this value, for you to load inside here, the instruction which allows you to load whatever value that you want into any memory location is known as literal oriented operation. Of course, we are not seeing the instruction. I'm telling any instruction that allows we as a user to enter a value inside a memory location, that instruction is known as literal oriented operation, or that instruction falls under literal operation category.
It allows users to
Enter the value inside the file memory location. Just now I gave example, assume got this value, assume got this value, but in reality we have to use the instruction from literal oriented operation category to actually load this value. Otherwise, how could the value be inside there? By default, when you turn on in the data memory, all the values will be 0 when you start off. So, just to wrap up, byte oriented operation, any instruction that performs the whole manipulation of byte will fall under byte oriented operation. Any instruction that allows you to copy and paste to another location known as byte to byte, and fortunate enough there's only one instruction. Under this category got so many. Under this there's only one. Under this got so many and so many. So what is bit oriented operation? Any instruction that allows us to just manipulate the bit only. Those kind of instruction falls under bit oriented operation. And literal operation is any instruction that allows us to load any values into 8-bit values. Any 8-bit values into any address of data memory. Is it okay? So tomorrow we will see each one of this has a particular format. How do you actually study the format? Okay, I'm too hungry to take attendance. So take attendance. Oh, everything is recording. Edit it out. Okay, thank you very much for coming. See you all tomorrow. Sorry.